Cool. Well, I guess we can start here. So thank you everyone for joining. Hopefully going to basically go through just some stuff that Dan and I have kind of worked on in the last little bit to kind of at least get kind of the team organized in terms of the software organization, specifically on GitHub. So myself, Dan, and a bit of Stephen have kind of worked together, kind of hopefully present this, and we'll hear feedback, and we'll kind of address any questions as we kind of go through. So overview of basically just the presentation, introduction to some new CADM stuff and repository naming conventions, a brief topic on semantic versioning, kind of outlining a possibility of a repository hierarchy, documenting the code and how it should be structured. Whoops, should have been updated, but a bit more on like the GitHub workflow, issue tracking, git ignore files, Jenkins pipelines, and I believe we get into some documentation stuff. So note on naming conventions. So as everyone's aware, we have CADM, configuration and data management system, which basically is all of our numbering for all the CSA documents. And I figured because we use it for everything else, why not we just adopt it for firmware? And so I've added, if you go to the Confluence page, I've added a firmware or FW, which then has an additional couple of prefixes depending on what sort of software that we're looking at. And so basically the idea is that we'll have a CADM ID for each individual subteam's software that relates to their CADM device. So COM, say, is COM001, and therefore should we have a COM001-FW for firmware. I think hopefully this is pretty straightforward. The only thing that kind of changes in terms of the actual CADM is the revision, and that we're going to follow kind of a semantic versioning. So we have 3 numbers. I'll get into that a little bit. But for the additional prefixes of the firmware, we've kind of broken it down in the event that some teams or as a whole team, we want to have specific repositories for specific functions. So we had DDR for device drivers, lib for libraries. If there's multiple libraries, you can just increment the number. OS for an operating system, PDR for peripheral drivers, RTL for register transfer logic or stuff to deal with FPGAs, simulation files, test benches, unit tests. Hopefully it's pretty self-explanatory. I know the way that we have defined what is considered a device driver and a peripheral driver may be somewhat confusing if you're not used to working with it, but typically, at least how Dan and I have kind of defined it, is that a peripheral driver is anything that is like non-microcontroller or non-CPU function calls, files, anything to support that. So an example would be external devices or external peripherals, such as the power monitor, INA233, the temperature sensors, or any sort of other sensors that we may have on board. Device drivers are things that are related to the microcontroller and how you actually talk to those peripherals. So examples of that could be certain communication protocols, certain drivers to configure the microcontroller's internal I/O pins and everything. And that's where we kind of set the designation, is that peripheral is everything off board, device is the specific device that you're actually programming on. So just an example, this is outlined in also the CADM thing, basically how we use all these. Basically, the example here is for the comms module. We have the 001, and then we have the parent repo, and then any sort of subsequent other repos. Chances are for comms, we're not likely going to have this, but it may be more applicable to when we have a common device drivers or a common peripheral drivers for the whole entire team. So moving to kind of how we would implement a repository naming convention based on this is we're going to move out a lot of the gubbins or whatever that we don't necessarily care about in terms of how we want it to show up in the repos. So I would remove, the CCP, NUDOS, because every team's going to have that and it really doesn't matter. I would also remove the revision number because the revision number should be tied within your releases and tags within GitHub. So examples here would be, com001 for the firmware. The reason we are keeping this number is because this is the firmware specific to the communications module, which relates to the actual CADM ID that we've outlined in systems, that the communications module is 001, where 002 is everything related to the antenna module. Similarly, device drivers, DDR. In terms of the system-wide repositories, we could start using system, because it's a whole entire system. And we could have basically, firmware, device drivers for the whole entire team. And this is kind of what we can use as a common base for the rest of the team to then pull into their repositories. So hopefully that's relatively laid out nicely. And we can start adopting some of this. So brief note on semantic versioning. For those that aren't aware of it, this is basically all you really need to know. It's broken down into 3 numbers. There's a major revision, a minor revision, and a patch. And you increment each one of those numbers depending on what happens. So a patch would be incremented, the lowest number, when you make backwards compatible bug fixes. So say you found an issue in software, you just need to have a quick bug fix. We're going to basically apply a patch. Minor revisions are where you add functionality, or you make your code more useful. You add that functionality, so that way it still works in a backwards compatible manner. So if I took a previous version, I would still be okay, but I would just be missing that new functionality. Say we added CAN and then we added CAN CSP. That is an example. Major revisions are basically when things sort of break if you go backwards. So if I can't necessarily go from a 0 to a 1 in the major revisions because its backwards compatibility is absolutely broken. And so typically what happens is it actually starts at 000, where we all kind of start, and you typically actually never hit 1.00 until you've defined what an API is. And an API is basically your application programming interface. The more layman term is basically just your use case of the code. How is somebody interacting with your system, and have we kind of confidently defined that? So that way, if we need to change how our use case is, say we want to use how comms is working, then we need to actually majorly increment this major revision because it's no longer compatible with the previous API. API is just a standard convention, I believe, is what they use. So brief note on our version controlling system. Obviously, everyone's aware we use GitHub. For those that aren't aware, you can actually just use github.masternews.ca and it just forwards you to here if you always forget what this is, as I do. Not that it's any more difficult, it's just the structure is different. Brief note that I know the PIs would be interested in is that all repositories are supposed to be private, unless they've been forked by other online repository sources, or they've been approved by the PIs. I think that's pretty self-explanatory. So in terms of how we'd actually structure our repositories, what we've kind of put together is possibly making definitely 3 kind of system-wide repositories. One for the peripherals, so the INAs, the temperature sensors, all of those peripherals that we kind of share as a whole entire team. Possibly the common ones for our device drivers. So CAN, SBI, I2C, if we all kind of use a similar structure, we can kind of store that all in one repository as itself, along with additional libraries such as libcsp, DSP, FATFS, any sort of external libraries that we are just importing and using as is. We can probably all share within one repository. The 4th one here has to do with operating systems. I added it in the CADM and all that, the naming conventions. I don't know how portable all the OS stuff is, specifically for RTOS, because I know every team is using it, but whether they need specific builds or specific versions of it is kind of beyond my scope. And then basically we need to define a folder structure so that way we can utilize these repositories as submodules. What else we need for? And as I kind of mentioned before, there may be a necessary need for a submodule for an own team. So what this kind of looks as an example is we would have a parent repository, say the comms firmware, and in there somewhere there would be a drivers folder, peripherals folder, some libraries, possibly an operating system, and we would link the drivers for our external drivers and our external peripherals and our external libraries, along with, you know, comm specific drivers, comm specific peripherals, comm specific libraries. And this is where I think our hierarchy of folder structure we need to kind of flesh out as a team. As I know, teams have different folder structures, and we unfortunately just didn't have time to kind of flush everything out to make a common basis for how these would actually be. But the idea is that we'd at least somewhere in there you would have a drivers folder, somewhere in there have a peripherals, and somewhere in there have a libraries. So adding submodules, for those that aren't aware of how they sort of work, when you're adding a submodule to a repository, you'll typically find that you'll get this git.modules file added as well. And what that kind of outlines is it outlines, you know, what the file path is local to the root of the repository, the path itself, and then the actual repository that it's linking to. You can have multiples of these depending on how many submodules your team has. To add it, it's very simple. It's just git submodule add your path, or your git address to where you're going, and then where your relative path you want it to be saved. Note, you don't have to have a folder having the same name as your repository name. You could rename it using the path function. So just a couple notes on submodules. You can actually change your working directory to be within, let's say, that folder for that submodule, and any sort of commits that you apply inside that actually gets applied to the repository. And what you have to make sure is if you're making changes to, let's say, your submodule, you then also need to go back out of the submodule and into your root repository to make sure that the latest pointing of the submodule is to the latest commits. And that's basically the last step that you should do when you're making your changes. There should have been a reference here to get submodule documentation. I'll fix that before we upload these slides. So that's it in terms of the folder structure. Now just going to kind of brief reminder of, you know, GitHub workflow. Basically this lovely diagram here, and the next couple of slides will kind of walk through that. So the idea is that, you know, anything in main or master should always basically work on the hardware, is I think a motto that the team should be following, especially as we move towards flat-sat and integration, such that if anyone is working on a system and needs to test certain specific functionality, we can always pull from our main or master branch to basically flash boards. And so we need to basically set up a rule for all these repositories so that you can never actually, it blocks commits to that main. And so what you would have to then do if you can no longer commit to main is you actually have to create a branch. So you create a branch, which basically won't affect the main at all. And it allows you to basically experiment and commit your changes as you kind of develop your new functionality or your new bit of code. This is all taken just from this reference here. So if anyone wants to read further about it, it's all outlined there. So I just had a quick look to see how we block branches. You used to be able to do it in here. So if you go to settings, branches, branch protection rules. However, typical, GitHub and everyone working online, they've changed what licenses we basically have access to, and they want us to pay money. So we need to, as a team, come up as an action item to find an alternative to how you can do this. I believe I was reading somewhere you can do like pre-hooks to your Git or to your commits and stuff like that to kind of loop around this. But we'll have to kind of find an alternative.
So it's still there. They've just moved it to settings.
Oh.
Yeah.
No. It's settings.
Yeah, there's somewhere, I don't know off the top of my head, but we have it on our damn repo. You block commits to main, and you need code reviews to get them in. So it's still there. They've just, that's for a much more
like specific branch. Yeah. Okay. Gotcha. Cool. Well, that's good to know. I knew it was here somewhere, but I had always gone to this spot and it had obviously moved. So it should be there. I can find it afterwards. So yeah, that you're in your branch, making your commits, whatever you add, edit, delete a file, you make a commit, add those changes to your branch. Basically, the actual branch that you're working on keeps track of all that progress for you. I think we're all hopefully well versed in this sort of workflow. Some fun things that I went through our repos and pulled out, good, meh, and bad examples of commits. So what we kind of want to see is something like specific, modify the canned drivers for interrupt for RX, fixed FreeRTOS config for CSP functionality. These would be like very detailed and very specific kind of commits to target certain files. Bad commits be, myself doing, mass update. I don't know. Don't even ask if this doesn't even work anymore because of GCC 9. These are definitely things we want to avoid. And then this one here is kind of commented as a meh or kind of in between. Specifically, it has to do more because of how these are related to binary files, but I kind of wanted to show that I'm trying to encapsulate. I've got great detail, but I'm trying to modify multiple files at once. I'm working on the microcontroller and RF transmitter at once, and they should almost be separate commits. So moving on to kind of a step 3, when we've kind of been ready to kind of create a pull request, so, our code's developed, we've tested it, it's working really nice, and we want to put it back into our main branch, you have to create a pull request. So the PR is actually what kind of initiates our discussion about commits, and it's our review process. We kind of review it A as a sub-team, and B as a whole greater arcing systems team. And so we can assign reviewers. There's all sorts of other stuff. I think the main important part is like reviewers, kind of like how we assign reviewers for schematics. We should be assigning reviewers for codes. And we'll get into a little bit like what stage certain people should be involved in what sort of a review. So, we've created our pull request. We're going to discuss and review our code. This is where we will hook into Jenkins. And Jenkins will have, whatever specific builds and tests that it does for your specific team. And it will actually should populate the pull request as, what passes, what fails, etc. In terms of kind of, at least what we thought of as a team, or between Dan and myself, is that for at different stages, we should have different types of reviews. I think it's relatively safe to assume minor and patch releases. We're developing functionality, we're fixing our own bugs. That sort of a review process could be maintained by the individual subteam. So comms, CDH, EPS, payload, where major releases, or we're about to actually like flash boards, like flight or engineering boards with this sort of code, should go through, a full systems review. And we can kind of discuss that as a takeaway at the end of this presentation. So step 5, basically, we've kind of gone through that review process. We're now just about to push it back into main. We are going to deploy the code. We're going to make sure it's working as expected on hardware. All of these last kind of steps are all kind of actually mixed together, but to outline them, it's just easier to just put them in procedure. But you should always make sure that your code works on the hardware and it works as expected. Basically, does your desired results meet what you are actually achieving? So final step is basically merging back into the main or master. Once merged, the pull request keeps a record of all that discussion, the fixes, everything there. And then this is kind of the point where we'd actually create a release, and we'd increment, whether it's a patch, a minor, or a major revision. And in terms of documentation, this presentation is basically the first shot at documenting this kind of process, at least for the whole entire team. I've also taken what Andre suggested last time we met, this Carleton's University's Rocket Design Team's repo, and put it within our own repository. But needing to actually kind of finalize it and update it to reflect this presentation and kind of our discussion that we'll hopefully have following this. With that, I will hand it over to Dea.
Okay, perfect. One thing before I continue, I think Paula, your mic is unmuted, so there's a little bit of feedback coming through. So if you could mute that, that'd be great.
I'm so sorry.
Yeah, that's okay. So yeah, issue tracking. This is sort of what we're discussing, and we can have a little bit of conversation about it later on. But basically, our main goal is to utilize Jira, which all our teams should be utilizing right now for issue tracking and sort of development progress of their subsystem, and to pair it with GitHub so that commits carry over into Jira and sort of allow you to connect with your timelines and whatever Kanban boards and what you have operating. We have enabled smart commits in Jira, and it's very straightforward in how you get this traveling over. Basically, when you send a commit, all you have to do is declare the Jira issue as well as including some sort of command. In this case, you can see the command is a comment with updated driver, and that will allow you to create a comment on the Jira issue showing that you've made progress on the work. If you skip over to the next slide, Aaron, you can see an example of this where we have, something that we're testing. We make a commit to, push this test file that we've created to our Git repo. And in doing so, we have a comment, some activity on the issue itself, so we can sort of be aware of that happening. And so this is really nice pairing between the two systems so that we can enable ourselves to keep all our issue tracking and all our progression analytics on Jira. That will also assist once we have our timelines working and our Gantt charts sort of generated from the issues that we've created. It'll allow us to sort of pair all of that together. This is also very nice to some other teams that may be more hardware based that are not utilizing software development. They can continue to use Jira and integrate their stuff with Jira so that we can all sort of use the same software. Yep, and so we've tested this. This works on the Git desktop app as well. So let's move on to the next slide. Okay, so then we have to talk about git ignore. So this basically tells Git what files are actually allowed to be published to the repository. It's really useful in blocking large files like binary files, as well as some other irrelevant files. Sometimes you want to not have the debug folders be included in your repository, and so it has a lot of effectiveness in doing that. So I recommend all teams have a git ignore and take a look at that reference that's linked in this presentation, which we'll share afterwards, so that you can implement it yourselves. Also note, when you're using Git, you have to make sure that your folder explorer is showing all these hidden files so that you don't miss any. And that'll be very important. I know we've run into some issues before. So also there are some issues that you can see linked in the examples below. Let us hop over to the next slide. Okay, so Jenkins. So we've mentioned that a little bit. I think everyone has heard of it. Some may not be fully familiar with it. What exactly is Jenkins? Jenkins is an automated testing and continuous integration software. So what this allows us to do is it allows us to test our software before we push it into our repos. And in doing so, it verifies a number of tests, whatever tests that we want to have happen have been done and have passed. It also enables some other nice, convenient data processing and parsing, such as performing Doxygen, a Doxygen parsing and generation of PDF files that can also be compiled and uploaded to the repository with your code. And so this sort of ties in, automated testing. We're not manually doing the testing now. We actually, build this on a, some sort of Docker that allows us to evaluate whether it worked before pushing it. And continuous integration, we're merging multiple developer environments of a code base to the centralized location. We have CDH has implemented a basic version of Jenkins. And they're fleshing that out further. Comms had a version of Jenkins as well that was performing Doxygen as well as a number of tests. Unfortunately, our version is down right now. We're working on getting it up again. Our goal is hopefully to have something that we can branch out to other teams as well. So as you all start performing, more regular software development, you can actively use Jenkins to support your development and make sure that all the information that you're pushing onto your Git repo is successful. Go to the next slide. Perfect. So now onto code documentation. So in our previous meeting, we were talking about exactly where should we organize our code and how should we do it and how should we organize our documentation. I think that we should pretty much produce as much documentation as we can. But we should make sure that we're placing this documentation in the correct locations so that we can access it and utilize it in a proper fashion. So there are sort of 3 levels of documentation that I think all teams should look towards implementing. A high level firmware overview of your software. This will highlight, peripheral requirements, different drivers that are necessary, the communication buses they're operating on, network addresses that may be relevant. And this information can be placed on Confluence. Confluence is very nice, especially with utilizing, a large number of images and regular updates can be very beneficial for that. Functional documentation, where we outline, specific functions in the code, what they do and how they work. And this is where we bring in Doxygen. And Doxygen just allows us to read comments and produce PDFs from those comments. And so this requires the foresight as you write your code to correctly label everything and utilize the correct formatting in your commenting so that Doxygen can correctly parse it and produce PDFs. Finally, there's installation and configuration documentation, and this should be produced in a README on your Git repository. And so all subsystems should have one of each of these for their main firmware development, as that will allow us all, especially teams that are not part of that subteam, to review and understand what's going on. So if we go to the next slide here, you can see an example of a high-level overview. This is from comms. We've essentially outlined a bunch of different drivers and the sort of software architecture that we're going to be using in order to correctly operate our module. And I think this is a very nice visual tool for other teams to take a look at in case they're curious exactly what's happening on our module, exactly what's connected where, et cetera, et cetera. You can see, which communication lines are connected to which peripherals and a number of other things, including the how libraries used, the specific communication buses, and so on and so forth. So this is the kind of thing I think would be nice to have from all subteams so that we can get a brief glance at what you've developed, what you're utilizing, and have a general overview of what's going on. In the next slide, we are talking a little bit about functional functional documentation. This is with Doxygen. You can see an example here. But basically, once you're releasing your firmware, once you get to those major updates that Aaron was talking about, you should have this implemented in your code so that it can be properly reviewed by other subteams. So you see an example here on our DAC driver. There is some commenting that has been performed on several functions like the set DAC voltage and power down. There's specific notation highlighting parameters, making a brief description and things like that. And then if you look to the right, you'll see what actually is printed out by Doxygen. You can see some diagrams on the connections it utilizes, as well as public member functions. I believe you can also see private member functions as well. They just have to be properly enabled in the Doxygen setup. So that's something that we're trying to correctly implement on comms right now. And then finally, this README. And so README must provide installation and configuration instructions, right? This has to be able to be utilized by any member on the team so that they can try and test the code, for instance, try and see if it builds at all or anything like that. And I think the DAM firmware Rev 3 has really nice instructions on not just getting started, which is what I've snapshotted here, but also a number of other things on how to actually work on this folder and what to do. And it's a really good template, I think, in order for us to, all the other sub teams to figure out exactly how to build their READMEs. I think this one is a very good example. So that basically brings us to the conclusion of this presentation. I wanted to highlight a couple of action items that sort of came out from this and things that need to be explored. For one, we need to create these new system repositories. These are the drivers and peripherals repositories. So we need to have these set up and start placing some drivers into them so that we can begin testing. At least on the comm side, we're going to start testing with this sort of new folder structure and accessing them. This also leads to restructuring team repositories. If you haven't set up yours yet, you can begin organizing it. And you can also try to move towards this naming convention that we're proposing to unify, all the naming architecture across the team. Well, we sort of resolved this main master branch in GitHub. Aaron and I will take a look at that after the meeting to make sure we know how to do it, and then we can update this presentation to reflect that. The next thing is the Jenkins pipeline. I know comms right now is working on getting ours up and running, and hopefully once we have ours up and running, we can use it as an example for the rest of the teams to try and implement their systems as well. Finally, I want to talk about the self-identifying of missing components for code documentation. So you notice I went through those 3 options for documentation. Please take a look and see whether there is a gap in your team's work that needs to be filled, whether it be the improvement of your READMEs, whether it be teaching everyone how to use Doxygen and start including it in their work right away, or this high-level overview of your software. It's valuable and important that we all start making sure that all our sub-teams have achieved all these targets. The last couple of things are involving this GitHub guides and manuals. Aaron has said that's uploaded, and we can take a look at that, and everyone can sort of go through that and try to understand exactly how to utilize GitHub to its entirety. And finally, making sure that our coding standard and file templates have been developed. We don't really have a coding standard yet. I know Andre has proposed some previously, and we can revisit those, but this requires further exploration. And I believe that is it for this presentation. So now I'll open it up to questions.
I guess one thing that we didn't really mention in this was kind of a naming convention for branches, because that might be a nice thing to do as well.
That's a very good point.
Yeah, like so like linking branches to maybe a Jira story or something using some sort of identifier.
Yep. Yep, that's a feature. I know that's a feature that we can start utilizing heavily. I know Columns actually has some of our branches linked to Jira right now, and so we need to we should add that to this presentation maybe. How exactly to link branches, how to organize it.
I think that's just you use the Jira item number, and then I think this part is just slightly different.
When you're creating a branch?
Yeah.
Okay.
Oh yeah, we can take a look and add it to your.
Mhm. Yeah.
Sounds good.
Thanks, Stephen.
Anyone else have any questions? Did we miss anything, or people like did everyone understand?
Do you mind going to the submodule slide?
Which one? This one? Kind of the example?
Maybe the next one. One after that. Oh yeah, this one. Just because there's a repo I'm working in now, I think we'll have to depend on, or it might be a good idea to add libcsp as a submodule. The slides will be released on Slack afterwards.
Yeah.
Okay, perfect. Yeah.
Oh, I also realized, I think I skipped over this. I don't know what happened, but cloning, there's also instructions here. When you have submodules, you need to do this recursive additional argument, or you could do it like this.
Awesome. Yeah, I'll have to look into this more. I think it might be ideal to have libcsp tied in as a submodule to some of the ground station work I'm doing.
Yeah, absolutely.
Yeah, because right now, I don't know, Daniel, if you've checked the README that I had recently, but essentially just says go download and execute it and all that. It's kind of but I think it'd be much nicer to have everything together.
Absolutely. Yeah, no, that should definitely be included as a submodule, and then you can change, of course, your README so that it reflects reflects that.
Yeah, for sure. I think even Albertasat has a repo somewhere where they have libcsp as a submodule, which was I saw, so I thought it was kind of cool.
I wonder. I think we do as well. Actually, let me check.
For the ground side software, though, we also we have to use some of the SDK libraries, and libcsp is included in that. So you might not have to add it in separately.
Yeah, I think there's a little bit of disconnect right now because we're just working towards SVX related stuff without using Gosh related terminals. Right. But you're right. Moving forward, we should definitely, if that's the case, then we don't necessarily need it. But it's good to be aware of it. Yeah, there is a libcsp fork in McMaster Udo. So
another thing that I just realized is we forgot to mention the network submodule that we were talking about for standardizing addresses and that sort of thing.
Oh yeah. We were talking about yeah, I don't know if it would fall. We have to figure out, I guess, where we want to put that.
Yeah.
Sorry, what are we talking about here?
You know how we said that we'll have routing tables predefined in a repository?
Oh, right.
I don't know where we would fit that
if we have
sort of structure.
Yeah, we would have to add maybe another network
ID or whatever.
Network suffix. Yeah.
Just use just net, that would work.
Yeah,
NET.
Net is fine.
We'll just use we'll use a systems and then net. Yeah.
Yeah, that's good.
If we're gonna have libcsp as being used with ground station and MOC stuff as well, then it could be worth putting the network includes in a libcsp submodule and then having everyone who needs to use it, including CDH, include that submodule.
Yeah, that's also an idea. So you're saying just stick it in with this guy.
I don't know if it should go with that though, because it's like that's separate. It's not a part of the library. It's kind of custom to us. Like when I like libcsp, it should just be like libcsp.
Okay,
Yeah.
that's fair.
Yeah, no, I think it's fine to have this network structure because it's also easy to find too. You know, if you have to dig through CSP's library, it could be a little bit more convoluted. So we can just have its own sequestered section where we can have the routing tables defined.
Because we're on this page, what's the thoughts of having a specific like OS repo? I don't know if it's a really like, smart choice. Question mark.
So it might be beneficial for some of the teams that are on microcontrollers, but for the DAM, it certainly won't work because we have to have quite a custom implementation of FreeRTOS for it to actually work with microblaze.
Right.
That's fair. I guess, does anyone know how much is different between the STMs and the nanomind, like the COM space FreeRTOS, or is it just straight FreeRTOS?
Don't know the specific differences, but it's provided as like part of the Atmel software framework, just as like you can get FreeRTOS as part of
The STM
whatever
framework.
Yeah, so
Yeah.
it's might not be worth having that.
It
submodule.
should be fairly portable for people on microcontrollers because FreeRTOS has exported a lot of their hardware-specific functions to user-defined application hooks. So those won't be portable. You'll have to write those for the board or the microcontroller that you're on, but FreeRTOS as a whole should be.
So what I'm thinking is that that's probably not worth our time in development to do those hooks and wrappers.
Well, you have to if you want to run FreeRTOS.
Right, but the IDE for STM does that for us. And
lucky.
the
Okay.
Atmel stuff does that for it.
Oh, you guys are lucky. Wow.
Yep.
Wow.
It's nice when you
okay.
have tools.
Easy peasy.
Yeah, Xilinx just hangs you out to dry. We had to implement all of that.
Yeah. So okay. So in that case, we'll scratch OS and we'll add a network basically.
Yep.
I think from that discussion.
Yep.
Flipping through just because I know there's some discussion, some thoughts or questions that Dan and I had as we're going through this. Fix that one. Does everyone currently use a git ignore? I certainly hope so. No, all right, no answer. Cool.
Take that as a yes.
Yep.
Emphatic yes.
Yeah, we're using it. CDH is using it.
Yeah. I think I've seen it in most projects.
Yeah. Maybe at some point beneficial to go back, revisit Jenkins when we have these pipelines properly working and show.
Yes, I think so. We have a member on the comms team who's working at getting it up and running again. And we have a previous presentation on Jenkins as well. And I'm hoping basically we can tie the two together. Once he has Jenkins running again and operating and performing our, build and debug testing, as well as our Doxygen PDF generation, we can walk through it with the whole team. So and of course, share how we implemented it so that everyone can set it up in the same manner and utilize it in the same manner.
Cool. In terms of documentation, is everyone cool with this sort of 3 structure? Again, I take your silence as a, a yes. Yeah, I guess if that's it, there's no more questions. We can probably stop the recording here.
Yep, perfect. Thank you, everyone.
Thanks, guys.